No, it'll never go away.
And in calculus. You'll need it in calculus too.
At this point, I would just tattoo it on your leg. It'll save you the trouble.
If anybody's watching the video, they're like, what did I come in on? Okay, so on the exploration 4.3.6 on numbers 1 and 2, write down that we're going to work those on the homework. Very good. Okay, so then on homework 4.3.6, we're just going to draw a couple of parent functions, which will be good practice for your test tomorrow anyways. Okay, so take a few minutes and draw your parent function for 1, 3, and 5.
This is the homework page?
This is the homework page, yes. This one's on the homework page. So draw your parent functions for 1, 3, and 5, and then we'll come back together and talk about 2, 4, and 6. Yeah.
Do you know if a protein container was left yesterday?
I did not see one.
Okay.
I
Yeah.
thought you were going to ask a chemistry.
I know. I heard biology coming on. Was like, Actually, Evan comes home every day now because he's in middle school, med school, and which is also known as 7th grade science.
Oh, okay.
Yes, that they call it
Health class.
And he's in health at the same time. So he comes home every day telling me about proteins and carbohydrates and things like that. I can't really say I remember much, but I'm getting a good science lesson every day after school. Yeah. It's kind of stressful.
Mr. Green moved, right?
He's the last I heard he was the head of the science department at Tuskegee Middle. But that was the last I heard, so I'm not sure.
I think that's right, yeah.
He really liked me.
He was here this morning.
Mr. Green?
Mm-hmm.
Is Miss Green here?
Mm-hmm.
Wait, Mr. Green was here?
Mm-hmm.
Why?
His wife, works here, across hall.
I got information.
Yeah. Riley visited me occasionally when he was here. My recording's picking up all this.
I'm sorry.
I said my recording's picking up all of this. Yeah. Hello, Jackson, Marie, and Braden. Yep. We're getting to hear our discussion today. Yep. I was down at the door with Miss Cozad this morning, and we walked through.
He's a good dude.
Yeah. He seems really nice.
go singularly.
Are the other boards No. Maybe you just check that. Yeah. My friends too. Miss Morris, why do we do the x-axis with pies?
Because we are working with our unit circle.
Oh, yeah.
So our unit circle, those points, work with those measurements of pies. Yeah. They're just numbers. Like this is like 3.14. So you could measure it in 1, 2, 3, 4 and put your point between 3 and 4 if you wanted to. Bless you. But just easier to do them in pies. I'm ready just in case they need to put me in the game tonight.
I'll cheer you in.
I've never played soccer, but I feel like I
It's
can do
more
well.
short one.
Should get Marley to come with me tonight. That's cool. Did you go sit on the other side and sit down?
That's so funny. No, that'd be
No, not funny.
because when they lose 8-0, you'll have to do the walk of shame.
What did you do?
Yeah.
The tangent graph? What did you do? The 1 over it. I don't know. I think just call something just looking at cubic. I didn't know that's cubic.
You're gonna wish it was a cubic though. Actually, it's literally.
I'm wondering what they're talking about.
Yeah, that is a cubic.
Like many cubic graphs with asymptotes. Yes, I see it. Technically, cosine is, bless you, a parabola, a reflected parabola, a parabola, a reflected parabola. Did I tell y'all about Evan getting the nosebleed in his nose?
No. That sounds sucky.
Okay, for that we have to pause the video. I paused. Right. Okay. Okay, I think it paused. Yeah, I think it paused and it came back.
Just a bunch of people in vests come
Right.
Hey guys.
Okay, let's talk about 2, 4, and 6 here real quick. So 2, 4, and 6 are working with the inverses. Okay, so think back to when we talked about inverses back at the very beginning of the year, and we said that an inverse is a switching of x and y. So what's going to happen is we're going to switch our x and our y axis. So I'll show you sine, and then I'll let you try cosine. So now my x-axis is going to be 1 and -1. And my y-axis is going to be pi and 2 pi. And then we can go this way, -pi and -2 pi. Okay, so what we're going to need to do is transfer the points of this one over to this one. Okay, so this one starts at 0, 0. So I'm going to still have a point at 0, 0. All right, then this point right here is pi over 2, 1. So my new point is going to be 1 pi over 2. So I'm going to go to 1 and pi over 2. Okay, then this point is pi 0. So I'm going to have a point at 0 pi. So 0 pi would be right there. It does. And then 3 pi over 2, negative 1. It's going to be negative 1, 3 pi over 2. And then 2 pi 0 is going to be 0, 2 pi. It's going to look like this. Okay, let's go the other way. So this point is negative pi over 2, negative 1. So now that's going to be negative 1, negative pi over 2. So negative 1, negative pi over 2 would be right here. Okay, then negative pi, 0, 0, negative pi, and then up to 1, and then back to negative 2 pi. Okay, so is this a function?
No.
No, okay. So my inputs have more than one output. Okay, so this one is not a function. Okay, so what happens now when we go to answer questions is we need to cut it off to where it is a function. Okay, so if you have a different color pen or a highlighter or something, I'm going to cut it off, and where we cut off a sine graph is right here at pi over 2 and right here at negative pi over 2. Okay, and we cut it off there because that then is a function. Okay, let me kind of block off some pieces here. Okay, so if I just look here and here, okay, see how that is now a function? Okay, and it also includes all of our values on our x-axis here. So it includes everything from 1 all the way to negative 1. Okay, so that's where we're going to cut it off, and that's going to be important here in just a minute because I'm only going to be allowed to use values to answer between 0 and pi over 2 and 0 and negative pi over 2, and I'll show you what that looks like in just a minute. Okay? Okay. All right, so take a minute and see if you can draw the inverse of cosine. So do that same thing. Take your cosine graph and draw the inverse of cosine, and then I'll show you where to cut that one off. yours if you're ready. Excuse me. Okay, also not a function, right? Okay, every input has multiple output values, and remember that it's going to continue to go on and on forever, up and down, right? Okay. All right, so I'm going to cut this one right here at 0, and then right here at pi. Okay, so if I cut at 0 and pi, and again, cover up here, I still have all values between 1 and -1, and now it is a function. So now each input only has the one singular output. Okay. All right, last one, give tangent a try. You're going to have some horizontal asymptotes on this one. This one's funny looking. You can just go to pi on this one. You don't have to go all the way to 2 pi. Just pi is enough. Remember, with our tangent graphs, we're in a period of just pi. Check yours if you're ready. And this one, to make sure it's a function, I'm going to cut at pi over 2 and at negative pi over 2. So I cut right there on the asymptotes. Okay. All right, so here's how I like to do this. Let's jump back over to the exploration just for a minute. So on the exploration, they've kind of given you this information right here with the range and with the domain. So my domain for sine and cosine, we're only working between 1 and -1 when we talk about an inverse. That's because we're just going between 1 and -1 on our x-axis. And then it tells you where to cut on your y-axis. Okay, so here's what I do. I draw this little picture next to all of mine, and this is for if I'm working with unit circle values. Okay, so this one is going to be for sine and tangent. Okay, and I said that I could work between pi over 2 and negative pi over 2. So if I have something that is negative, I'm going to answer with a negative angle. And it's not okay to use like 11 pi over 6. You have to use negative pi over 6. It does make a difference. Okay, so I'm going to use these angles here. So for sine and tangent, I can use pi over 6. I can use pi over 4. And I can use pi over 3. That's going to be if sine and tangent are positive. Okay, so they're going to give us a value like 1/2, and if it's positive, I want to work with one of those answers in the first quadrant. And I'll show you what that looks like here in just a minute. If they are negative, then I'm going to use negative pi over 6, negative pi over 4, or negative pi over 3. Okay, so again, I don't use 5 pi over 3, I don't use 7 pi over 4, and I don't use 11 pi over 6. You have to call them the negatives because that's where we made the cut on the graph. Okay, so if you look at this, like 11 pi over 6 would be way up here. Okay, but we said we need to work down here at negative pi over 6. Do you see the difference? Okay, all right, so that's why it's important that we have to use those values, or those angles. Okay, but for cosine, we said that we could work between 0 pi. Oh, I didn't put my negative right here, I'm sorry. This is going to be if sine and tangent are negative. I forgot to include that. Okay, for cosine, I'm going to work between 0 and pi. Okay, so just like sine and tangent, if cosine is positive, I'm going to answer with pi over 3, pi over 4, or pi over 6. That says pi over 3, pi over 4, and pi over 6. This cosine is positive. Okay, but if cosine is negative, I'm going to jump over into the second quadrant. So I'm going to be over here at 2 pi over 3, at 3 pi over 4, or at 5 pi over 6. Okay, so you have a very limited amount of answer choices for these. Your answers will either be, if cosine is negative, 2 pi over 3, 3 pi over 4, or 5 pi over 6. Okay, so you'll never, never, never use the third quadrant. And we won't use the fourth quadrant for cosine. We won't use the second quadrant for sine or tangent. Okay, now this is only if we're working with unit circle values. Unit circle values. Okay, and I'll show you the difference here in just a minute on E. Okay. All right, you have your unit circle right there in front of you. Let me draw my quadrant one real quick. All right, so we're only talking about if you're asking us a question about one of these values here. So if it's a 1/2, a square root of 3 over 2, a square root of 2 over 2, a square root of 3, and you have all this on your unit circle, which you can use. You can use your unit circle. Okay, I like just working with this quadrant 1. Okay, so let me remind you that cosine is x and sine is y. It's just been a while since we did these. So cosine is x and sine is y. Okay, so A is asking us to find where my x value is 1. Okay, so these inverses mean that I'm trying to find an angle. Okay, so ask yourself the question, where is cosine 1? Okay, so look at your unit circle. Where do I have a cosine value of 1? Cosine, x. Good. You're good. Yeah, right. Yeah, that's right. Good, right here. 0 pi. Good. Okay, so right here at 0 pi, I have a cosine value of 1. Good. All right, so my answer is going to be at 0 pi or just at 0. Either way is fine. Okay, here's where we get a little harder. Okay, next I'm going to work with tangent. I want to know where is tangent negative square root of 3. Okay, so tangent are my values that I write out over here on the side. Okay, so the first thing I'm going to do is find out where is tangent the square root of 3, which is right here at pi over 3. So because it's tangent and it's negative, I'm going to jump down here and I'm going to use negative pi over 3. Okay, so your sine and tangent, if they give you a negative value, then your angle will also be negative. Okay, cosine is different, but for sine and tangent, if your value is negative, your angle will be negative. Okay. Any questions on that one? Okay, let's go a little harder. Okay, on this one, I'm going to start by finding the cosine of pi over 3. Pi over 3 is just an angle, so I'm going to work it the way that I normally would with my unit circle. Okay, so look at your unit circle. Cosine is x. At pi over 3, I have the value of 1/2. Okay, so I'm going to start with my inside, and I'm going to say that the cosine of pi over 3 is 1/2. Okay, now I'm going to go and find where is cosine 1/2, and that would be back at pi over 3. Now let me warn you that they don't all cancel each other out. So that was kind of an inverse cosine that canceled out a cosine. Okay, it doesn't always work that way. It depends on the angle that you're being asked. Okay, like on D. Okay, all right, so on D, I'm going to start from the inside. I'm going to find the cosine of 4 pi over 3. All right, so on your unit circle, 4 pi over 3 is in the third quadrant, where cosine is negative, and I have a pi over 3 value of 1/2. Okay, so on your unit circle, cosine is negative 1/2. Is that right? Let's make sure my answer. Am I doing okay? Okay, good. Okay. All right, but now I don't want to use 4 pi over 3 because that's in the third quadrant, and with cosine I can only use in the first and the second quadrant. Okay, so for my negative, I'm going to jump over here in the second quadrant, and I'm going to say that my cosine value here is at 2 pi over 3. Okay, so you have to make sure that they kind of match up with either the first or second quadrant for cosine and 1 and 4 for sine and tangent. Do you see the difference? Okay. All right, the last one that we'll do together, and then I'll give you some time to practice, is this one. 4/3 is not a unit circle value. Okay, so when I'm talking about tangent, I'm only talking about square root of 3, square root of 3 over 3, 1, 0. Okay, so if you have one that isn't on the unit circle, it's going to be what we call a triangle problem. So I'm going to put a little triangle next to it so that we know that this is a triangle problem. Okay, with a triangle problem, I'm going to use the inside to draw. So this is going to help me draw the triangle. Okay, then what's on the outside is going to tell me how to answer. Okay, so the inside piece tells you how to draw your triangle. The outside piece tells you how to answer. Okay, these rules still apply. Okay, so if I was drawing a tangent that was negative, I would want to draw it in the fourth quadrant. Okay, if I was drawing a cosine that was negative, I would want to draw it in the second quadrant. Okay, we'll get some practice with that. I'll work with you on the homework. All right, so let's start with this tangent. This tangent is positive. I'm going to work with tangent being positive in the first quadrant. Okay, so let's draw a little picture. Remember, when we draw triangles, we draw x on x, y not on y, and theta at the origin. Okay, by giving me tangent, they've given me my opposite over my adjacent. So my opposite side will be 4, and my adjacent side will be 3. Okay, what's my hypotenuse going to be? 5. That's right. Good. This is a 3, 4, 5. If it's not a Pythagorean triple like 3, 4, 5, you can use Pythagorean theorem to find your missing side. Okay. All right. So I've drawn my triangle. I have all of the sides. I'm finished with the inside part. Now the outside is going to tell me how to answer. So it's telling me to answer with sine. I know that sine is opposite over hypotenuse. So that's going to be 4 over 5. All right, let me stop this.